In an experiment, 2.4 grams of sulphur, 2 of sulphur was obtained by reacting hydrogen sulphide and chlorine as shown. Which of the reactants acts as a reducing agent in the above reaction? So to know that, you need to find the oxidation numbers of each species that is reacting. So let us rewrite this equation here so that we can calculate the oxidation number of each. So the oxidation number of sulfur here, the oxidation number of sulfur there is -2. So sulfur here is -2. Chlorine here is 0 because chlorine is a gas, so all elements and the molecules are 0. Oxidation number 0. Sulfur is 0 here, and the chlorine here, the chloride ion here is actually -1. So how do you know? If you want to know oxidation number for this one, for sulfur, you say X plus hydrogen in moja, so 1 times 2, 2 will be equal to 0. So X is equal to -2. Hii kifuka pande hii itakuwa -2, so ndio maana tumepata hii. This one is 0. If you want for chlorine here, you say 1 plus X is equal to 0. So X is equal to -1. Ndio maana hapa -1. So you can see hydrogen sulfide, the oxidation for hydrogen sulfide increased from -2 to 0. That's an increase. So that means this is oxidation. Then chlorine, we can see the oxidation number moved from 0 to -1. Is that an increase or a decrease? That one is a decrease. So this is a reduction. The species which undergoes oxidation, you need to know. The one which undergoes oxidation is the reducing agent. The species which undergoes reduction is the I've said the species which undergoes oxidation is the reducing agent. The species which undergoes reduction is the oxidizing agent. So I hope I have explained this one. Now we are going to answer the question. So to answer the question, hydrogen sulfide is the reducing agent. Is the reducing agent. Reason? This is because oxidation number of sulfur increased from -2 to 0, and that is the reason. Given that the yield for sulfur in the above reaction is 75%, calculate the number of moles of hydrogen sulfide gas used in the reaction. So first let us get 100%. What is the mass for 100%? Because 75% inatupea 2.4 yenye ilitumika. What about 100%? So 100 times 24, 2.4, sorry, 75. This one will give us 3.2 grams. So 100% is 3.2 grams. So let us find the moles of sulfur. What we are using, the information we were given here, that 2.4 of sulfur. So now we are going to calculate the mass, the moles of sulfur, because now we have the RAM of sulfur, which is 32, which is 3.2, the total mass. Now moles of sulfur is equal to mass over RFM, and that is 3.2 over 32. So it means moles is 0.1. So the moles of sulfur is 0.1. From the equation, again, if I take you back, the mole ratio for sulfur and hydrogen sulphide is 1:1. You can see, so the meaning that the moles of sulfur will be equal to the moles of hydrogen sulphide. Having that in mind, we will say that moles of hydrogen sulphide will be equal to the moles of sulfur is equal to 0.1 moles, because they have the ratio is 1:1. So moles of hydrogen sulphide is equal to 0.1. Hiyo ndio tuliulizwa moles of that.